Hello, my name is Todd. I'm going to be your logic tutor today. Today I'm going to introduce you to the rules of proper inference, all these rules in this box down here, so that we can use them in a process called natural deduction to prove that an argument is in fact valid without having to do a massive truth table. The very first thing is to understand these rules of proper inference, to know what you can do with them, and then worry about remembering the names. So let's try to understand them, and we'll start with modus ponens first. What modus ponens is saying is, suppose that you have a substitution instance of 1 and 2, these are premises, then you can deduce 3 as following from 1 and 2 by the rule modus ponens. So, for example, if we have P, then Q, and we have P, suppose that these are premises, then we would know that Q would follow from 1 and 2 by the rule modus ponens. Okay. Now, since these shapes, we use shapes in our system to stand for variables, anything that fits into the argument form of modus ponens, if you have an instance of 1 and 2, you may deduce 3. So, for instance, we could have something like this: S or T, then not F, S or T. Those are premises. Let's 1 and 2 premises. Well, we could deduce from these two not F, and we would write 1, 2 modus ponens as our justification. So notice there's no negation signs in our rule of inference modus ponens, but it doesn't matter because 1 and 2 are still substitution instances because those shapes represent variables. One other thing to know, and that is that the order that the premises come in doesn't matter. So long as you have instances of 1 and 2, you may deduce 3. Let's take a look at another rule of inference, modus tollens. One thing we need to talk about before we really think about modus tollens is this notation that we have here, this n with brackets and some variable inside. What this means for us is the opposite of, okay? The opposite of whatever's in here. So suppose that we have P, then Q, and we have not Q, then, if these are our premises, we may deduce not P from 1 and 2 by modus tollens. So, the n brackets represents the opposite of. So, this is an instance of modus tollens, but so would this. Not Q, Q, not P. So this is a Q, this is a not Q, they're opposites, so we get the opposite of P. Or if we had not P, then not Q, Q, we would get, since these are opposites, we would get the opposite of not P, which would be P. Okay? That's modus tollens. Hypothetical syllogism is pretty easy to understand. Suppose we have P, then Q, Q, then R. Well, from those two facts, we know that if you have a P, then you'll get an R. Okay, and if these were premises, we would say that 3 is true by looking at 1 and 2 and thinking about the rule hypothetical syllogism. Remember, the shapes are variables, So long as anything fits into or is a substitution instance of 1 and 2, you may deduce the corresponding substitution instance of 3. So for example, suppose we have not, and let's just make something up, B if and only if F, then Z, Z, then Q. Well, if we knew these two things, these are premises, we could deduce not B if and only if F, then Q. And that would come from 1 and 2 by hypothetical syllogism. Okay, moving on. Disjunctive syllogism. So we're again using this notation, the N brackets, which means the opposite of. So if we have P or Q and not P, we get Q. Right? See how this is a substitution instance of that argument form above. Now notice one thing, and we're going to be particular about this. We have the opposite of the first disjunct, okay? And then we are allowed to conclude the second disjunct. But we could ask this question. Suppose we had not Q. Doesn't it follow that P? It does follow that P, but this is not allowed by our rule because our rule says, our rule disjunctive syllogism says if we have the opposite of the first disjunct, we get the second disjunct. Okay? We will have a workaround later such that we will be able to deduce P from P or Q, not Q. Okay? Let's do one more to make sure we understand this here. Suppose we have not F or Z and X. We have F. These are our premises. What can we deduce? Well, F is the opposite of not F, so we get the second disjunct, which is Z and X. We would say this is true from 1 and 2, and our rule here is disjunctive syllogism. Another one, simple dilemma. Okay, this is the first rule of inference that has 3 premises involved, and some textbooks lay it out just using 2, but we're going to use 3. So suppose we have P or Q. If P, then R. If Q, then R. Well, what follows from that? Well, R. Right? We have one or the other, P or Q. If it's P, we're going to get an R. If it's Q, we're going to get an R. We have a P or a Q, so either way, we're going to get an R. Okay? So if these were premises, we would say R is true for 1, 2, and 3 by simple dilemma.